Welcome to the first video on chapter 3. So we're going to begin with 3.1, which is on congruent triangles. So now when two figures are congruent, it means they're the same. So any two shapes can be congruent, but we're going to look at these two triangles first. So these two triangles are congruent, and what that means is this side is equal to this side is equal to this side, and this side is equal to this side. Now, so basically these two triangles have the same side lengths, so that means they're the same, and because of that, that means that the angles are also the same. So this angle is the same as this angle is the same as this angle here, and this angle is the same as this angle. Now we can see that these two triangles are congruent because all parts of them are the same, and so if you put them on top of each other, they're going to be the same, and so they're going to match up. And so that's what it means for two figures to be congruent. It means they're the same, and for two triangles it means they're the same and all the sides match up and the angles. Now that we've gone over 3.1, let's move on to 3.2, which is about side-side-side congruency. And so what that is, it's how to prove that two triangles are congruent. So if we look at these two triangles again, so one way to prove that these two triangles are congruent is to prove that all their sides are equal. So that means if this side is equal to this side, and this side's equal to this side, and this side's equal to this side again, then that means that these two triangles have to be congruent because their sides are the same lengths, and so they match up. And so that's called the side-side-side congruency theorem. It's also known as SSS congruency. And so this is one of the ways to prove that two triangles are congruent, if you can prove that all their sides are equal. And so now I'm going to go over one of the problems in the book, problem 3.3. So I've taken the liberty of drawing out 3.3 here. And so what it asks is find angle MLN. And so the way we're going to do this is to prove that these two triangles here, you see them, they're in here, these two triangles are congruent. And so the way we do that is that obviously this angle is equal to this angle because they're both 17. This angle is equal to this angle because, they're both 9. And this angle is equal to itself. And so you see that we have one triangle here and then one triangle here. So we can say that these two triangles are congruent. Now this brings me to my next point, which is basically called CPCTC. And that is corresponding parts of congruent triangles are congruent. And so what I mean by that is we have two congruent triangles here. And what CPCTC means is that because this angle is 25, that means this angle right here is also 25. So this angle is equal to this angle, so this right there is 25 degrees. And so that's what CPCTC is. So another example of this would be, let's say I did not have this 9 right there, so I don't have that. But I have this 9, and I know that these two triangles are congruent. I can figure it out that by using CPCTC here, that we can figure out that when these two triangles are congruent, that this side's equal to this side, so this side must also be 9. And so that's what CPCTC can do for you. One last thing before we move on to 3.3. So what they want you to know is if a radius of a circle bisects a chord of the circle that is not the diameter, then the radius must be perpendicular to the chord. So what that means is if this radius right here bisects this chord, which is not the diameter obviously, then this must be perpendicular to this, so this has to be 90 degrees and all that has to be 90s. So what they want you to do here is they want you to draw triangles, and so the way you're going to do that is you draw two lines right there in there. So then you move on and you go, okay, this line's equal to this line, you're already given that. Then this line equal to this line, and then finally this line is equal to itself. So you have two triangles here, and they're congruent to each other because of side-side-side congruency. And so now you know that this angle right here is equal to this angle right here. So these two angles have to equal to 180. And so you just go 180 over 2 is equal to 90. so that you know that this angle right here is equal to 90 degrees and this angle right here is equal to 90 degrees. And it's the same way for this angle and this angle, they're both 90. And so you can see that this radius is perpendicular to this chord because it's 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And so this might come up later as a problem if they ask you to find all this right here. And so that's what they want you to know from 3.2. Next here we're going to jump on in into 3.3, which is on side angle side congruency. So what that is basically we have the two triangles here. So if we can prove that this side's equal to this side and this side's equal to this side, then what's different here is if we can also prove this angle is also equal to this angle, then we have side angle side, side angle side, and that we can prove that these two triangles are congruent, which is side angle side congruency. And so the reason why side angle side proves that two triangles are congruent is, if you think about it, you have, so let's look at this triangle. You have two lengths that are the same. So this is the same as this and this is the same as this. So right off the bat these two are the same. And then you have the same angle splitting them apart. So for this line here, this line has to be the same length as this line right here, because this is the same angle as this, and these are the same lengths. So the distance between this point right here, and this point right here, and this point right here, and this point right here is going to be the same. And so that's how you can prove that two triangles are congruent by side angle side. Now, before we go on to 3.4, I wanted to go over a problem in the book first, and so that's problem 3.8. And so what they're asking is for us to prove that dB, the line dB here that goes up and down, they want us to prove that that is perpendicular to AC here. So the way we're going to do that is by using what we've learned so far. And so first we say that basically dB is equal to itself. So then we can say that triangle ADB is congruent to triangle CDB by side congruency. And so now, because these two triangles are congruent, we can say that this angle right here is equal to this angle right here. So now we have that triangle ADE is congruent to triangle CDE because of side angle side. So you see that this side's equal to this side, and this angle is equal to this angle. And so you know that DE is equal to DE. So basically you have that these two triangles are congruent. And now that you have these two triangles are congruent by CPCTC, you also have that angle AED is equal to angle CED. And so because these two angles have to add up to 180, you can just go that 180 over 2 is equal to 90. So now, because you know that this angle is 90 and this angle is 90, that means that this angle is also 90 and this angle is also 90, and you can do the whole thing just like that and figure out that line DB is in fact perpendicular to line AC because it's 90 degrees here, 90 degrees here, 90 degrees here, and 90 degrees here. And so that's how you do that problem, and I'll see you in the next video.